We're going to talk about what logarithmic functions are. So logarithmics are just the inverse of an exponential. So the exponential is the y to the b to the x that we've been working on. So that makes logarithmic in the form of x equals b to the y. But we like to write it as y equals log base b of x so that we can see that the log is within it. So we like to change between the log form and the exponential form of the logarithmic. So we take the base, is then our big number. We then go over to the next one, and that becomes our exponent. And then we come back around, and that becomes what it's equal to. So it's the same kind of concept when it comes to going exponential to logarithmic. We always start with the log and that first number. So we go the log and the first number. We skip over to the fraction, which is what to what it's equal to, then that's what we write next. Come back around to the power, and then that's what it's equal to. We can also then solve them by essentially thinking if this is equal to x, then 8 to what power would equal 16? This, as you can see, is 4/3. So it might not always be a whole number. So this is where a lot of guess and check comes in, and trying to play with things and putting in one and seeing you get the other. So when we do, we take the first number, 15, skip over, that becomes our power, equals, we come back around to 225. Same thing, so our first number is the first big number we write, we go over to -3, equals, come back around, 1/27. You can check these and make sure they're right. 15 squared is 225. 3 to the -3 is 1/27. So we find our first number 4, flip over to our power, 5/2, come back around, and it equals 32. Same sort of concept when you change into logarithmic form. So the first number is the first number you write, which is going to be that little subscript. So it's going to be log base of 2, skip over to the 128, equals, go to that exponent of 7. So log base of 3 to 1/81 equals -4. Log base of 1/7, move over, of 1/343 equals, come back around, so we get 3. Just like log base 7, come over, of 149 equals, we come back around, we get -2. So log base of 2, go over, of 512 equals 9. And one more time, log sub of that 64, we come over of 16 equals 2/3. Okay, so that's a lot of just changing between forms and understanding how it works, because then we get down here to the math part, you have to understand how that works. So we want to think of these as equal to x. So we want to think 4 to what power equals 64? Well, we know that's 3, so we know that x equals 3. So the value of log sub 4 of 64 is 3. So we want to think 2 to what power equals 64? Well, we know 2 to the 6th equals 64. So the value of this would give us 6. We can say x equals 6. So same thing, 100 to what power would equal 100,000? Well, if we just put in squared, that doesn't give it to us. If we put in cubed, the number is too big. So then we want to think what number is between 2 and 3. So we tried 2 halves, and coincidentally that works. X equals 5/2, or 2.5. This is where a lot of guess and check could come in, and just paying attention to the answers and seeing what you could get from there. So we write this, 5 to what power equals 625? Well, 5 to the 4th equals 625, so x would equal 4, or the value of this would equal 4. Then we get 27 to what power equals 81? Well, 27 squared is too big. So then we try 1 1/2, and that's too big. That's too big. So then we have to change fractions. So we try 1 1/3. That works. So we know that 27 to the 4/3 gives us 81. This is where we use our calculator and we do a lot of guess and check. But then some of them we can make educated guesses. So 5 to what power? To what power equals 5? So we know it needs to get smaller, so it's going to be a fraction. We know the square root of 25 is 5, so we know x is going to equal to 1/2, because square root is the same as the exponent of a half. Just like we can use our knowledge of this. So 2 to what power equals 1 over 128. So we can think 2 to what power equals just 128. That's 2 to the 7th. We know it's going to be flipped to the bottom, so we know that 7 has to be negative. Same thing with this one. We want 10 to what power equals 0.00001. We know it needs to be negative because that could also be written as a fraction. We play it in our calculator, we guess and check, and we get x equals -5. Then we want to know 4 to what power equals 1 over 32. Well, we can start with just 4 to what power equals 32. 4 squared, 16. 4 cubed, 64. It has to be halfway between that, so it'd be 5 halves, or 2.5. We also know it has to be negative because this 32 needs to get to the bottom. So that tells us that x would be -5 over 2, or -2.5. It's easier to do the fractions, even though I know you guys all don't like fractions that much, but then you don't have to worry about trying to put this in parentheses. It's a little bit easier. But remember, when you're putting these in the calculator, you need to put these in parentheses when you're trying to figure those out. So make sure you watch all of this, and you come to class on Tuesday with your questions and ready to practice some of this.